In this lecture and the next one, we're going to look at how to take specific data values and find a quadratic function that passes through them. Now, if you think back to our discussion of graphing, we saw that in general, you have to have three distinct points to find the graph of a quadratic equation, or just two if one of them was the vertex. So when you're trying to find the equation of a quadratic function, the same two rules are going to apply. Right, so in this lecture, we're going to take a look at the case where you have 2 points, one of which is the vertex. For example, let's take a look at this situation here. We have a quadratic function. We're looking for a quadratic function whose vertex is at negative 3, 2, and that passes through negative 1, 3. So to start this off, I'm going to start with the vertex form of a quadratic equation. Not surprising, right, since we know the vertex. So remember that in this equation, h and k are the x and y coordinates of that vertex. So I'm going to take negative 3, put it in here for h. I'm going to take 2, put it in here for k. That's going to make my equation y equals a times x minus 3 quantity squared plus 2. And before I do anything else, let's just straighten out those negative signs, right? Make this y equals a times x plus 3 quantity squared plus 2. And now we can find that a variable. And if you feel like we're really in pretty good shape, right? We have three things we needed to fill in, a, h, and k, and we've already done 2 of them. So to find that remaining parameter, to fill in something for that a value, this is where I'm going to use the other point. Okay, so I'm going to put 3 into the equation for y. I'm going to put negative 1 into the equation for x, and that's going to give me this. You notice this is just a linear equation, right, in one variable. So I can solve this for a. Negative 1 plus 3, that's 2. 2 squared is 4, so this becomes 3 equals 4a plus 2. Subtract 2 from both sides, divide by 4, and we get a is equal to 1/4. All right, now we can get to the final answer. I'm going to take that 1/4. I'm going to substitute it back into this equation. That's going to give me y equals 1/4 x plus 3 quantity squared plus 2. Okay, if this were my class, I would be perfectly happy with this as an answer. Right? This is a perfectly good representation of the equation. Your teacher, your professor may feel differently. They may feel that for the answer to be complete, you need to multiply this out. Right? You need to multiply out the x plus 3 squared, distribute the 1/4, add the 2, and really make this look like an ax squared plus bx plus c type of quadratic equation. And if you do that, if you want to work it out here, you get this thing. Y equals 1/4 x squared plus 3/2 x plus 17/4. Like I said, I'm not picky about this. I would take either one. This is a case where you really need to follow up with a teacher of your class and just make sure you're clear on what their expectations are. Okay, so that's the 2-point where one is the vertex case. Yeah, in the next lecture, we're going to take a look at the other case where you don't know the vertex, right? Where you just have 3 kind of random points that are on the quadratic function.